Okay, we're going to go ahead and start the geometry unit. The nice part about this unit is it's the last full unit for the year. Yoo-hoo! Now, in this unit, there's a lot of information to cover, and so I've gone ahead and split it into 2D and 3D geometry. We're going to start with 2D geometry, meaning two-dimensional figures. First thing to note is that you've got to be able to know how to calculate perimeter. Yes, I know it's review, therefore it should be easy for everybody. We know that perimeter is the sum of all sides of a polygon. So what we have to do when we are doing perimeter is we add up all of the sides. So we added up 5 plus 4 plus 5 plus 2 plus 4 plus 1. And we've ended up with 21. Now there's no units on this figure, so we use the word units on our answer. Perimeter. Now, perimeter is the sum of all sides in a polygon. Circles are not polygons because polygons have sides, they have straight edges. A circle is round. Therefore, we use circumference. Circumference is basically perimeter of a circle. And there are two formulas you have to know. The first formula is pi times diameter, or we can say 2 times pi times radius. So things to note are that pi is going to be 3.14 unless you're told otherwise. Diameter is all the way across the circle, going through the center of the circle, and radius is half of the diameter. So my recommendation is learn one of these. You have to know one of them at least, because if you can figure out how to get between a radius and a diameter, then all you have to know is one of the formulas. Or you can memorize both, your choice. For the first one, we have a circle with a diameter of 18 inches. We know its diameter because it's going all the way across the circle. So we know that that is the diameter. And we know the formula is pi times diameter. So we're going to say 3.14 times 18. And we end up with 56.52 inches. And so we know it's going to be inches. Now we come across to the other circle. We note that it's only halfway, making it the radius. Therefore, we know the formula is 2 pi r. So we end up saying 2 times 3.14 times 7. And we get 43.96 units, because we're not told any specific unit of measure. Notice that in each of these situations for circumference, when we had a formula, I wrote the formula, I plugged the numbers in, and then I solved it. That's going to be the expectation going forward. You write the formula. Yes, you're allowed to abbreviate. Notice I didn't write out pi, diameter, radius. But I wrote the formula, then I substituted in my values, and then I got the answer. Biggest reason that we've got to see these steps is because it's going to let teachers and people know if you make a mistake, where was the mistake? Was it the wrong formula? Did you plug in the numbers wrong, or did you type it in the calculator wrong? Those are the three areas that you can easily make mistakes, and we need to be able to figure those out if you make those mistakes. Going on to the next page, you'll notice we're doing area of polygons. So area is going to deal with the amount of space inside the figure. Perimeter and circumference are dealing with outside. Area is going to deal with inside. Our formulas for area of a rectangle, we know it's going to be length times width. So if we're going to do L times W for this rectangle, we're going to multiply 12 times 7. Traditionally, people usually assign length as the long side and width as the short side, but it's not necessarily always going to be the case. So as long as we can see that you know the formula was L times W and you knew that 12 and 7 were your dimensions, that's all you need to worry about. And we end up with 84 centimeters squared. Now on to area of a triangle. There's two formulas you can use. Base times height divided by 2 is going to be the easiest one if you're using a calculator that can't do fractions. One you've probably seen is 1/2 times the base times the height. You can use either formula. Teachers don't ever have a preference. One thing you need to note is that base and height are formed at a right angle. Biggest confusion for a lot of students, not so much in two-dimensional, but for sure in three-dimensional geometry, is identifying what's the height and base of a triangle or of a figure. And so if you can locate that right angle box, it's going to make life a lot easier on you. So taking a look at this first figure, we know we're going to do base times height divided by 2. Easiest way to locate the base and the height is to locate that right angle box, because that box is going to be what tells you the base and height are. So in this case, the base is 24, height is 7, or you can do base is 7, height is 24. Doesn't matter, either way. And we end up with an area of 84 inches squared. Notice that on both of these, for area of a rectangle, area of a triangle, area is going to be squared for your units. The number is not squared, the units are squared. Looking at the second one, we know we're dealing with base times height divided by 2. So we locate that right angle box to tell us that the base will be 14 times the height of 5. We divide by 2. Here's where it's easy to see that students might get confused because they want to put either 6 or 12 in as the height. Height and base always have to meet at a 90-degree angle. They're always perpendicular to each other. We multiply, divide, and we get 35 units squared. We know it's going to be units because we were not given any units. Going on to the last one. It's a triangle, so we know we're finding the area, which is going to be base times height divided by 2. In order to locate the base and the height, we need to find that right angle box. Now for each of these, I've given you 3 different situations where you can find the height of that triangle. One is a right triangle, which is super easy to do. One is where the height is on the inside. The third one's going to be the height's on the outside. So in this case, we know the height's going to be 6, but the question is, what's the base? Students a lot of times want to include that 3. However, that 3 has nothing to do with the base of the triangle. The only thing we have to note is that the height to get from where the uppermost of the triangle is to the bottommost point of the triangle is 6 feet. That base of that triangle is going to be 10. You do not need to combine them. A lot of times students want to combine them to make the triangle bigger, but if you combine the 10 and the 3, you've gone and changed the dimensions of the triangle and you've made it a bigger triangle than it actually is. So we multiply and we divide, and we end up finding out the area of this triangle is 30 feet squared. Now let's take a look at 2 other types of quadrilaterals that the expectation is that you know the formulas and that you are able to calculate the formulas. Please note that all the formulas you're being given today, or in this video, are ones that the expectation is that you memorize, because we are not going to give them to you. I have handed them to you, you have written them into your book, and so therefore this means you have them memorized whenever you have a quiz or a test. Parallelogram. A parallelogram is just a rectangle that's kind of been pushed over a little bit, so it's leaning like the Leaning Tower of Pisa. We know that area of a rectangle is length times width. In a parallelogram, because it's slanted, we can't use length times width, but we do base times height. Some students learn the formula for a rectangle is base times height, and I'm fine with that if you choose to learn that one instead of base times or length times width. So we know we're going to do base times height We know that a base and height are going to be found at a right angle. Well, in this case, we're not given a right angle, but we note that the height is going straight up and down. So in this case, it's going to be 12 times 8, which is 96 feet squared. We know that there is an invisible right angle right there to tell us that's the base and the height. Looking at the second parallelogram, base times height. Really quick and easy to find that right angle to indicate that the base is 10 and the height is 5. So we do 10 times 5 and we get 50 inches squared. So once again, base and height. The height can be drawn on the inside of the figure or on the outside of the figure. And here's just two examples of where you can find the height of that figure. It will not be the slanted side. Never, ever, ever will it be the slanted side in a parallelogram. The final two-dimensional figure for area, the final two-dimensional polygon for area is trapezoid. Now, area of a trapezoid, the thing to note about a trapezoid is the definition states that you will have exactly one pair of parallel lines, meaning that you have one pair of sides are parallel and one pair of sides are not. For trapezoid, the two parallel sides are never going to be the same length. One is always shorter than the other. They are not congruent. So we're going to use this idea of a triangle's formula, that's base times height divided by 2. However, with the two bases being different lengths, we can't just say base times height divided by 2. So first thing we do is we combine the bases. We find the sum. Base 1 plus base 2, it does not matter what you call base 1 plus base 2, times height divided by 2. So for this first one, we're going to do base 1 plus base 2 times height divided by 2. We know that we can find the height of that figure and the base of that figure by locating that right angle box. So base 1 usually is thought of as the smaller side, so that's 8 plus 14 times the height, which is 6, divided by 2. Notice I wrote the formula and then I filled in my numbers. So what we are actually doing is saying 22 times 6 divided by 2. And we end up with 66 feet squared. Now looking at the last one, we know we're going to have to combine our bases first, because we do base 1 plus base 2 in parentheses times height divided by 2. So we know that base and height, look for that right angle box, and we end up with base 1, usually the smaller one, plus base 2, usually the larger one, times the height, which is found at the right angle box, divided by 2. So what we're actually doing is 14 times 4 divided by 2 to give us 28 units squared, meaning it would take 28 little squares to fill in that entire trapezoid. Looking at the last page in our area and perimeter circumference section, page 12, we notice that we're finding area of circles. Let's remember that a circle is not a polygon and therefore it gets its own special formula. Now, when you are little, you are taught the nursery rhyme, Fuzzy Wuzzy was a bear, I imagine. And the nursery rhyme goes, Fuzzy Wuzzy was a bear, Fuzzy Wuzzy had no hair, so Fuzzy Wuzzy wasn't fuzzy, was he? Well, an easy way to remember the area of a circle formula is to say a nursery rhyme like this, but we're going to change it up a little bit. Fuzzy Wuzzy was a bear, area of a circle, pi r squared. Fuzzy Wuzzy was a bear, area of a circle, pi r squared. What this means is 3.14 times r, or 3.14 times r squared, in which r is the radius. It has to be the radius. With circumference, you could do diameter. With area, you cannot. It has to be the radius. So let's take a look at this first one. We're doing 3.14 times r, which means the radius happens to be 7. We've already know this. So we do 3.14 times 7 times 7. If you prefer, you can do 3.14 times r squared, which means it's 3.14 times 7 squared. No matter how you go about it, you get 153.86 units squared. Again, I've given you 2 ways to solve it. It depends on how comfortable you are with the exponents. So I know some students get confused by r squared and what it means. So if that is you, you can use the times r. Now moving on to the last one. We know that the formula is going to be fuzzy wuzzy was a bear. Area of a circle is pi r squared. So we can do 3.14 times r, or we can do 3.14 times r squared. In this case, we have a diameter. So we have to take our diameter and we have to divide it by 2 to get that the radius is going to be 9. So we do 3.14 times 9 times 9, or we do 3.14 times 9 squared. Again, it all depends on what your level of comfort is with that exponents. No matter how you go about it, you get 254.34 inches squared.